functions now. So 3.2 getting into functions. The last one was relation, so things can be related. Now functions have like an actual more distinct meaning. So we're gonna go through like domain and range and like all these things when we go here. So domain versus range. So the set of the first elements of a relation is called a domain. So pretty much that first circle that we had, these would typically be like our x values. If you guys think back to that unit in grade 9, they're going to be like our domain values. And then our range is what's going to come out. So quite often this is considered like my input, and your range is considered your output. So like domain, they're all the values that you're putting in, and your range are all the values that you're getting out. Okay, and that's kind of the idea of a function. You put things in, you get things out. All right, so that would be the same if we go back to that other lesson there. Your range values would be like all of these values, and your domain value would be all of these values, and your range values would be all of these ones. Okay, and in your ordered pairs, your domains would be all of your first values, and your ranges would be all your second values. Okay, so a function is a special type of relation, and this is important, so put a star by this one. A function is a special type of relation where every value in the domain is associated with exactly one element in the range. In other words, for any value of x, there is only one value of y. Okay, so let's look in this example, right? So like they're saying, in other words, for any value of x, there is only one value of y. So does that kind of make sense so far? So if we had 2, so one value of x, there is only one value. There's only like one value for that, right? So it's going straight across. Same with these ones, right? This is okay that we've got, so for 6 and 8, we've got 2 values of y going on there, right? So, but it's not going to be okay if we've got, let's say, from one value of x, you've got multiple values of y coming off. So you've got like 2 different ones coming from that x value, if that makes sense.
You can have 2 y's, but not
if it says here one value of x, any value.
Okay, so you guys are good with that one?
Sure.
So you just can't have multiple y's for one value of x, if like when we're thinking in terms of x and y, or you can't have multiple ranges for one domain value. Okay, and that's just like a terminology thing. It's just what's considered a function. Okay, so for each relation, identify the domain and range of each relation, and determine whether the relation is a function, and then justify your answer. So for this one, if we were going to write out the domain of this one, quite often the way we do that is you'd write a D and then dot dot. It's just like shorthand for domain. And then again, we're going to work on our squiggly brackets. I'm getting worse.
I love squiggly brackets. I can't draw.
Okay, so squiggly bracket. And then our domain values are all of our like x values here, right? So that's going to be 4, 6, 6, 8, and 9. But so we don't need to write the 6 multiple times. It's just going to be 4, 6, 8, and 9. And then close the squiggly bracket.
How do you squeeze?
You just draw 3.
And then our range,
Squiggly bracket.
quite often we write as just capital R and then like dot dot, just short for range. And then those are going to be all of our like our y values or our output values. So then that's going to be 2. We don't need to write the 2 multiple times. So then 3, and that's it.
This is
I'll just make a bunch of squiggles. Like 33.
All right, so
33. Oh, never mind. It's just
okay, so let's now think about whether or not this thing is technically a function. So is this thing a function? What do you guys think?
now.
Why would you say no?
because there's 2 6.
Yeah, so for any one value of x or one value of our domain, there should only be one value of y, right? So, but in this case, we've got multiple coming from that, right? So we've got 6, we've got 2 and 3 are associated with that. Does that make sense? So for that one value of x, we've got multiple values of y. So not a function.
I mean, it makes sense, but like. Well, I understand how people just
All right.
stick it under a table.
Okay, so domain of this one now, so it says, so the relationship here is has this number of days, right? So January has this many days, right? February has this many days. Yeah. Okay, so domain and range here, so we'll say, okay, domain, so D will be, and then it'll actually just be those months. So we'll say domain would just be January. All right, Jan, February, March, and April. Okay, our range would be 28, 30, and 31.
Why don't we just do it this square bracket? Can we just do that?
No, they mean different things.
Do they?
Yeah. Squiggly bracket pretty much usually is like a way of like putting information between those things. It's meant more for like arrays and yeah, things like this. Where like a square bracket is more for like calculations. Okay. Okay. So is this a function? This is a function. You can think about where there's not multiple arrows coming from like the one, like January doesn't have 2 arrows coming from it, right? It's okay that they both end up on 31. We just can't have 2 arrows coming from the same one. Okay. So is a function.
Well, if you think about it this way, wouldn't it be correct to have February?
Okay, so if you guys are in science, have you guys talked about independent versus dependent variables?
Science?
I just remembered.
Okay, so independent versus dependent variables would be, so if you had, well, let's look at this one. So it says, well, here, I'll do the definitions here first. So the independent variable is a variable for which the values are selected. The value of the dependent variable depends on those in the independent variable. So that's a little confusing, but let's look at an example. So it says, the Canadian National Frog Jumping Championship is part of, however you say that. This annual festival is in St. Pierre, Manitoba. The first championship, a frog named George jumped a distance of just over 2 meters in a single leap. Assuming that George could maintain a distance of 2 meters on every jump, the total distance traveled from the start is measured as a function of the number of jumps. The table to the left represents the function. Since the distance depends on the number of jumps, n is the independent variable and d is the dependent variable. So what they're saying there, so n in this case, what did they tell us? So n is the number of jumps, right? So the number of jumps to begin with is kind of what's going in. So if you've got 0 jumps, you've got 0 distance coming out. So now the number of jumps, if the number of jumps is 1, then the distance traveled depends on the number of jumps. Does that make sense? Like the distance you go depends on like how many jumps you actually take here, right? So if you take 5 jumps, then the distance that comes out is the 10. So I usually think about like which one depends on the other one, right? So the dependent variable depends on the other variable there. Okay. All right. So sake of time again, I'm gonna skip through that one. You guys can. All right, get into the good stuff now. So the way function notation is gonna work. So let's look at this example. So it says, consider. All right, so consider, for example, a student Ron who currently has $100 and saves $15 each week. The value V of his savings is a function of the number of weeks that he saves. So, and here's an equation for it. So we actually set these equations up last year in grade 9 too, right? So this is really just saying if he had $100 to begin with, so just constant value, $100 no matter what, then it's going to be $15 times the number of weeks that go by, right? And that'll be his total amount of money. Okay? So Another way of writing this using function notation would be like this. It'd be v, and then this looks a little different. It'd be like, it's like a subscript. It's v of w. It's like v and then w beside it, like in brackets, is equal to 100 plus 15w. Now, the reason why this is like kind of a new thing and why we use it is because I can write this thing out different ways. I can say v of, and then instead of w, I can actually put in like the number of weeks that have gone by that I want, right? So I can say v of 3. And what that would mean is that after 3 weeks, how much money would I have, right? I could put in v of 4, and then that would tell me how much money I have after 4 weeks. It's just a way of writing it so I can just be clear about what it is I'm actually solving for here. Okay, so we can always just throw different numbers of weeks in there, 1 week, 2 week, 3 week, 4 weeks. But if I want to tell the reader, somebody who's looking at my math here, then I could say, like, yeah, like in this example, v of 2 is equal to 100 plus 15, and then we're going to put a 2 in everywhere that there is a variable, everywhere that there's a w in this case. So then you'd solve it and get 30. So this is a way of saying after 2 weeks, she has $130. Yeah? Okay, so not so bad. We can do it with other things. So if we had like a circle in function notation, we could say a of r is equal to pi times r squared. Well, pi r squared is just the formula for the area of a circle, right? But when I write it this way, with a of r is equal to that, what I'm kind of saying is that now I can throw whatever value I want in for r and then get out whatever the area would be. So I could throw in this case, they threw in 4. So if I had an area with a radius of 4, or sorry, a circle with a radius of 4, so I'm inputting 4, so then I just rewrite the equation, but instead of an r, I'm going to put a 4 in there. It's just like, this one's just telling me what to put in for my variables, right? You guys are good with that? And then pi times 4 squared, so I can say the area of a circle with a radius of 4 would be equal to 50.3, whatever the units were there. Be like meters squared or something, right?
Can you ever square? Let's say, can you square pi? Not that. Can you ever make a square?
All right. One bit of confusion that can happen with some of these sometimes is that what we were doing last year and what we still do quite often is we'd write something out as something like above there, y is equal to 4x minus 7, right? That is a function, right? That's like an equation. This is a 2 variable equation, right? I've got y is equal to something x. It's a 2 variable. But this y, you guys are going to get really good at this, especially like as you go through like 20 level and 30 level. Y is almost exactly the same thing as writing like f of x. We do that quite a lot more, where it's like a function of x is equal to 4x minus 7. Yeah, so you guys are going to see it kind of written both ways. Yeah, so and again, you'd say f of x is equal to that. This is kind of the standard way that we write out functions. Okay. Let's just do one of them. I'm just going to do the second one here, again, just for time's sake. So it says the equation C is equal to 25n plus 100 represents the cost, C in dollars, for a feast following an Arctic sports competition where n is the number of people attending. All right, so now it says, let's write this thing in function notation. I'm going to pause it. All right, so not as bad as we think. In function notation, all that's going to change here is just going to be this C. We're just going to write this where we can actually write it like a little different, where we can like have an of x thing, or of n in this case. So we can say, okay, when we put a number in, what comes out? So this would just be C of n is equal to 25n plus 100. And now it's kind of set up that I could say, I could put in a number like 2, like C of 2 is equal to, and then replace the n with a 2 or something like that, right? Okay, so now B says, determine the value of C of 100. Okay, so C of 100. That's not C times 100, that's C of 100, the way that we're in there. So that would be this. It'd be saying C of 100 is equal to, and then it's going to be 25, and now what is my n going to become? 100, right? I'm inputting 100, right? That's what this was telling me to do. C of 100, so 25 times 100 plus 100. Okay, so C of 100 is equal to, okay, so what you guys end up getting? So this part would be, yeah, 2,500 plus 100, so this would be 2,600?
Yeah, no, it's 25,000. You're wrong, I'm right.
Okay, so there we go. That's it. So, and just remember what we were doing here. So we were saying, so N was the number of people attending. So this was saying if 100 people attend, we would make $2,600, right? Input and output. The input was the people attending. The output was the value that we got out of it. Okay, so now the other one, and this is the point of confusion that always comes up. Now they're saying determine N. So determine N so that C of N is equal to 5,000. Yeah, we got to go backwards, yeah. Yeah, so this can be a little confusing, I think, where people just don't know what it is they're asking for, right? Good. Just to get to that point, let's rewrite this out again. This was C of N was equal to 25N plus 100, right? Okay, so now C of N was equal to 5,000. So that means that this, right, C of N would be 5,000. That's my output. The way that this is written, they're saying that my output is 5,000. This is saying that it's like, what value of N would give me $5,000, right? It's like asking it the other way around. So it's your guys' job to kind of like figure those two, like how those are different, right? How B and C in the example are different questions. But anyway, so what this means is that we're going to have 5,000 instead of C of N. And that's equal to 25N plus 100. And now I'm just solving for N. So, okay, I just need to get N on its own, right? So the 100's got to go and the 25's got to go. Which of those goes first?
100.
The 100, right? And how do I get rid of it?
Divided by 25. Divided by 100.
Subtract 100 because I'm adding right now. You always do the opposite of what's being done, right? So we were adding, so we'll subtract 100.
Wait, isn't it? Yeah.
So we subtract from the other side. So 5,000 divided by minus 100 would be, and that's equal to 25N. Okay, one more step. Right now we're multiplying 25 by N. So we're going to divide both sides by 25. So divide by 25, divide by 25. 196 is my N value. So we just solved for how many people would have to come in order to make $5,000.
Wow.
That's our N value.
196.
That's a lot of people.
Yeah.